I'm really excited, not only to speak with you, but I'm excited about this product. I've been working in security for about 25 years, data analytics for about the same. My first job out of college was at Bell Labs. I got to work under Bill Cheswick on the loosened firewall, which some of you may have heard of, called the Brick. And I mean, heck, that was a great first job. How often do you get to work with people whose names are on the books that are on your shelf? And I've been back and forth between vendors and in implementers. So I really like doing that because my experience in actually being a security professional lends itself to being able to come back and talk to the actual products. Say, hey, this is probably how we should do it. So this product that I'm working on right now. I'm director of product management for search at Cribl. Is for me, it's the product that I've always wanted to have. If I had this 20 years ago at AT&T, we could have done so many different things instead of having to build Sun clusters with S3 disks attached to them. What we're doing is we're leveraging our experience, as Jim said, of being able to take data and look at it at the source. And we've developed 3 or 4 years of expertise in that field of really understanding data where it is. And we said, hey, maybe we can approach the data analytics problem a little differently. So I'm going to cut through most of the slides and get to the demo, essentially, because we're a little low on time. But essentially, if you look at this slide here, most of your data analytics tools kind of look like this. You collect your data somewhere, you put it somewhere else, and then you go look at that data. There's time involved in that, there's infrastructure involved in that, there's cost involved in all of that, right? So eventually you get your data somewhere, you ask it a question, and great, you can get your answer. And we said, well, maybe there's a better way. This data, we are at the I want to say at the precipice, but we're sort of in a space in technology where we have a lot of infrastructure available publicly. Public cloud, SaaS providers, we have all this compute available that we can rent, we can lease, and the question is, why should we have to centralize the data? Why should we have to bring it somewhere? Why can't we leverage data and the compute where it already is? Right? So Cribl Search was designed with that idea in mind. Don't centralize your data. Don't move it around. Don't schlep it from here and there. Don't try to jam it into some vendor proprietary system like a roach motel where you can never get it back. Just leave it there. Leave it on your public infrastructure. Leave it on your own personal infrastructure. Leave it on your file systems. But be able to ask it questions. The biggest trouble with throwing data into S3 is it's opaque. It's a black box. You end up wanting to ask it questions. You have to write code. Search allows you to ask questions of the data where it is. We support Amazon S3. We support Microsoft Azure. We support Google Cloud GCS. So you can have data in any of those 3 places, ask it questions, and you get the exact same experience as if that data was in your analytics system on your premise or in your cloud, with no ingest, with no latency. You get the answer immediately. And since search is integrated into the Cribl suite, if you then want to take your data and push it into your SIEM, push it into a different vendor, then you can send it via stream. Every mechanism that Jim just talked about, you can then use in search. Now, this is actually a federated, distributed model. So not only can you ask questions of the data of each one of these 3 major cloud vendors, by the way, Amazon Security Lake is also supported. You can ask questions of them simultaneously. So you can ask a single question, the search gets pushed to the data, your data executes locally, your compute executes locally to where the data lives, and then what comes back is results. And it gets federated, integrated, and all you see is a single result set. Now this is done with a single language, a single user interface. So we're actually using Microsoft's Custo language, KQL, which is, again, a declarative language. And we've all had experience with Splunk, so we understand that sort of pipeline approach to a declarative syntax. And it is really, it's a nice open source language, so it's easy to use, it's easy to extend. But of course, since each one of these endpoints, again, Google Cloud and Azure and AWS uses sort of a different interface, we take care of the hard job of doing the translation for you. So you ask a single question, and we will translate the language to the appropriate platform-specific syntax and then give you the result back. So imagine that, being able to take your data in S3 and the same type, semantically similar data in Azure, and ask it one question and get the result back without having to go to each one of those providers independently. Like, let's say you have firewall type data, right? You have VPC flow logs in AWS. You have Azure container data in Azure. You have Google firewall data in Google Cloud. And what you want to know is who's hitting port 443 or port XYZ, right? I want to know inbound source IP address. And I don't care where the data lives. What I care is the answer to my question. With Cribl Search, you ask one question, the search gets dispatched to each one of those providers, and what comes back is a single, unified, federated set of results without any data movement whatsoever. We see this as the future of data analytics, massively parallel, massively federated. You can also, in this version, ask questions of REST APIs in the exact same way. So if you have a RESTful API, let's say we have it hooked up to Okta, you want to know authentications over time for the past 3 hours, great. You can do that. You can then create a lookup table for that, do that data fusion from Okta into, let's say, your Azure login logs, your AD logs coming out of Azure. So the whole point is you can ask questions of where it is, of the data where it is, but how do you pay for all this? Well, the great part about Cribl Search is that the only thing you pay for is the search itself. So there's no ingest, there's no transport fees, there's no data movement fees. You simply pay for the CPU that's involved in the actual search. Questions on that?
So do you call this data virtualization, or is it you just refer to it as what you just said?
This is massively federated data search,
Okay.
right? We're trying to meet the data where it is, right?
Yep.
So our whole approach is we're not looking at it as data virtualization so much as it is search virtualization, if you will.
Okay.
Right? We're taking the search and moving it to the compute that happens to be convenient for where the data is. Mm-hmm. Incidentally, we also support the Edge product that Jim mentioned. We can push searches to that as well. Mm-hmm. So if you have Edge deployed, let's say you have Edge deployed on 1,000 of your machines. A great use case is CI/CD, right? You push a new version, something, you're running it locally, and you have 15% of your clients are reporting similar errors. Now that data is transient and not something that you necessarily want to store. You don't really need to centralize all those logs. You don't want to push them in S3 and waste storage. But you were very interested, the developers are very interested in those 13% of clients who are reporting that error. Now, what are you going to do? Tell them to SSH into 130 machines? You can, if you have the Edge agent sitting on those machines, you can ask one question, it gets pushed to all 1,000 of the machines, and you get back the results instantly from each one of those machines that have the appropriate results on them, without ever having to move the data elsewhere. So it gives you that ability to interrogate the data where it is.
1 second,
please,
David. So, Karen, does that make sense why we're not calling it data virtualization?
I'm not asking you to justify that. I was just asking if you referred to it as that. So, I mean, there's a lot of overlap here, right?
Sure,
sure. And there's a lot of sort of, the whole data gravity issue. You don't want to move data around. You want to run things on the compute, like take compute to it and not steal compute from it, and all of those things. So,
but the trappings of data virtualization, as far as having kind of a normalized schema and things like that, having to map data sources, that's not here.
That's not what I mean in data virtualization. Okay. So we can save that for the.
Okay, yeah, we can talk about that later. Thanks.
So Cribl Edge is a pretty important part of the conversation, I think.
Right.
You led this with, you can search data that's anywhere and you don't have to move it, and then told me there were 3 sources in the big three clouds, and then brought up Cribl Edge later, which really filled in a pretty important part of the solution for me.
You bet, absolutely. And there are actually 10 different what we call data set providers. And so quick little terminology, a data set provider is an endpoint that has storage and potentially compute. And as you said, we have the big three, your storage providers, which also provide compute. Four, if you include ASL, Amazon Security Lake. And then we have on top of that Cribl Edge, which allows you to basically push that compute to any place where the edge agent will execute. And finally, 6 different API solutions. So those REST APIs endpoints that are in here. So and those are called data set.
Do those include things like SIEMs where we have a lot of data stored too, or is it just application?
It does not at this moment include SIEMs. Because generally speaking, SIEMs don't publish their APIs. However, we do support Splunk's binary data format. So we can actually search into Splunk data. In fact, if you have Splunk Cloud and you're using the DDSS solution, the dynamic data self-storage, where you're allowed to, where Splunk Cloud will age your frozen data into your own S3 bucket, we can search into it.
Okay, yeah, because if I'm doing a security search, I mean, obviously my SIEM's got to be part of the search domain.
You bet. In fact, this just happened to us recently, where one of our customers called us up and said, "Hey, we had a security event and data aged out of Splunk, and we're interested in searching through that data, and we helped them get data, find the event in the data that was in S3 within about 12 minutes. Splunk took 14 hours to rehydrate that data from cold storage." So they were pretty pleased about that. And their analysts, who were chomping at the bit to get this data, were very happy with the results. So yeah, absolutely. So to the extent that we can, we certainly want to. And this is obviously a moving target for us. We're going to continue to add data set providers. On the screen, I'm showing you sort of the list of what we support right now. As I said, the big 3 object stores, ASL, Edge, and specific APIs. We don't have a generic REST API connector yet. We're kind of learning as we go and making sure we nail these specific ones, because these are kind of the ones that are important, especially given the 3 providers that we have. So we have one of each of the APIs for each of them, as well as Zoom, Okta, and Google Workspace. And there's a number of endpoints at each one of those that we support, so you can, again, ask your questions. So that's a data set provider, and a data set is a named set of data that lives at a data set provider. So let's say, whereas in Splunk, I'll draw the analogy here, or the simile. If you're in Splunk, you would have started a search with index equals or source type equals. In Cribl Search, you start a search with data set equals. Okay, so let's just show you the basic search. I'm just going to click on Cribl internal logs, and you can see this sort of experience has a very similar sort of look and feel. Most SIEMs, most analytic systems kind of give you this. You get a result set, you get fields parsed on the left. You have a set of events down on the bottom here. Let me sort of squish it down. And what you're seeing here is the raw events in event form. There's also the table view as well. You can look at it that way, where the fields are actually parsed out. And again, I'm going to go through this very quickly, so please stop me if there's something you want to say. So, and now here, what you see here is that the built-in metadata fields are in sort of gray background, and then the fields that are parsed out of the raw event are in white. So we can do simple unstructured searching as you would expect. Let's just type in a keyword up here, or what is going on here? There we go. So I'll type in get, and it's going to give me all of my, all the events that have that simple string in them. So again, no rocket science there. But now we see that field, for example, or that data appears both in the message and the method fields. So we could convert that into a structured search by typing in method equals get in the exact same way. Here, let's invert it just to make it fun. So method is not equal to get. And you get your results. Now, this is all running on local data. I just kind of wanted to give you that experience. But I can take that exact same experience and translate it over to Cribl Search Sample. Now, Cribl Search Sample is an S3-based data set. Let me show you how we connect to S3. So here's our data set providers. I'm going to click on Cribl S3 Sample Provider. We connect with assume role, as you would expect and hope. We also provide keys for the daring and possibly unwise. So basically, and actually, I really like this interface. We give you the trust policy template and permission policy. So for those of you who aren't AWS experts like me, you can easily take your basically your trust policy, copy it from here, open up your S3 IAM editor, create a role, also create a permission policy, and you notice we pre-provision the the ARN of this particular instance. And again, Cribl Cloud is a single single tenant provider, so you get your own Cribl Cloud instance, and there's nothing shared. So this ARN is the ARN of your particular Cribl Cloud instance pre-provisioned. Then once you're done and you've configured a role in AWS, you get back the ARN of that role, you copy and paste it here. Now what you've done is you established bidirectional trust between this particular instance, your instance, and your AWS account. So then once you ask it a question, we spin up transient compute in our account, and then that can access the S3 bucket in your account. So the only thing you pay for is search. There's no data export fees because it's running essentially in our account, not yours. And there's no compute because, again, it's running in our account, not yours. So let's just take a look at that same experience, right? So I'm just going to click on search now. Now this search is running directly in AWS. This data is coming directly from S3. And you notice it's a little longer, but so 7 seconds versus 4 seconds for local data. And you'll see that there are, in fact, 3 different types of data that we got back from S3. syslog, VPC flow logs, access common. We've parsed 2 of them. We left the third unparsed just to show you how that works. And if you take a look at it, you see, for example, this first one looks to me like a VPC flow log. I open it up, and sure enough, it is, in fact, a VPC flow log. And you see up here, IP addresses and ports, as you might expect. We've auto-detected that it is, in fact, a VPC flow log. And boom, you've got all the IP addresses and ports as you might want. So now let's maybe drill down into this. I'm going to click over here, VPC flow logs, and I'm going to say something like, again, I'm a firewall guy. So what I want to see is aggregates based on source IP addresses and destination IP addresses, for example. So I'm going to tell it to summarize, please. And notice I get type ahead. Summarize is going to do count by. So let's do source address, comma, destination address. Boom, boom, boom. Good. And notice I've still got a limit 1,000 in there. So you're kind of training wheels as we're building up the search. And as you all know, searching is often iterative. You kind of, I got Rose nodding, right? As you're building a search, you kind of go, oh, what about this? What about that? For me, I banged my microphone. Sorry. My tolerance for search latency is about 12 seconds. If I don't see a result in 12 seconds, I'm stopping and starting, right? We designed this product with that degree of sort of anxiety and snappiness. We want you to, time to first byte, we want it to be in the seconds, not minutes, right? So we're going out of our way to give you intermediate results. This isn't like SQL, you write a question, you go out, get a cup of coffee, come back and see if you got a result. Right? This is intentionally, we're giving you intermediate results so you can see if the thing you asked for is in fact there. So look, we just generated this cool list of source addresses, destination addresses, and now I can actually iterate on the results here. I can hide this visualization if I want. I can do something like, let me do a sort by this. So great, here we got some IP addresses. So I can include this one, I can include this one, and now I can go back and say, all right, let's get rid of all of this stuff and just look at these two, this pair of IP addresses, right? So now I can just look at that. Did I get that right?
A quick question.
Yeah, please, by all means. Go ahead, Bruno.
Bruno Wallman here. And you might have covered this. I might have missed it as I was tweeting away, but does every search go out to every edge agent, or is there some pre-work involved in categorizing that? Say you've got 1,000 agents out there, but a certain query is only going to go to 100 of them or 500 of them. Is there? How do you pare that down so that the query doesn't hit every agent if you don't need it to?
Sure. That's a great question. So remember that since this is massively federated, we're going to a variety of different endpoints, including Edge. So Edge, S3, Google Cloud, Azure, things like that. So each data set, that's why I'm showing you this visual, each data set maintains a one-to-one relationship with a particular data set provider. So by specifying the first term of the search to be one or more data sets, the system knows specifically where to go. Now, if you're, so this data set happens to be an AWS data set. So if I actually just make a new tab here from home and look down here, this search sample, you see we've got a cool little AWS icon there, indicating that is, I'm pointing at the screen, you can't see, but this data set is in fact only an S3 data set. So it knows how to get to that particular endpoint because of the definition. However, if this was an edge data set like these here, for example, Cribl edge logs, I can specify subsets of my edge fleet. So edge agents can be partitioned and organized by what's called a fleet. So you could say have a number of your edge agents, let's say on your compute cluster, a number on your external web servers, a number on your database layer, a number on your middleware layer, and you can give them all names, but then they're called fleets. So you can specify a particular sub-fleet over which you want to search so you don't always have to search across them. This, for example, just went out to 4 different EC2 instances and got all their logs immediately. And again, it just pulled those back without having to do anything. Right, so those were local just on those machines and didn't move anywhere. Does that answer your question, Bruno?
Yeah, it does. I guess just a follow-on question to that is that those seem to be statically categorized, at least the edge ones. Is there a way to make a dynamic data set? So say only query agents that live on Windows 2012 or 2016 servers, just, to throw out an example there.
So right now, the way
sets, I guess.
So right now, the only flexibility you have in Edge, in searching Edge, is by specifying fleets. So you basically would have to specify a fleet that had just those Windows machines. But certainly that's something we could add is more designators that gave you more granularity in which parts of your fleets you would search. But again, once you actually do that search, like for example, let's say you have a naming convention on your hosts that specify the role of that machine. You could easily include a wildcard in your search. So for example, I could click here and say, all right, and it'll add the host to that. So for example, I could say I only want to search things that are in US West 2. Right, so I can include the wildcard in that expression, and then I would only get results in that particular area. So as long as there's a way for you to designate the specific subset of data that you're interested in by using a field that we know about, then the answer is yes. Okay.
Okay, perfect. Thank you.
Thank you. Okay, great. So I just wanted to continue once on this VPC flow log thing. So now what I did was we pulled up this particular set of particular results, right? And we have 32,000 results. Not super useful to have 32,000 results in my browser, right? I'm not going to do anything with that. So let's say I want to reload that data into my SIEM, or even load it into my SIEM if I wasn't actually putting that into my SIEM in the first place. In fact, one of the most common use cases we have is customers taking data that they're not loading into their analytics tool, just putting in S3, and then searching it. Right? So rather than saying, all right, we're going to throw all of our data into our analytics product and then pay for it by ingest, we're going to throw only a small fraction of it in there, and the rest of it is just going to go into overflow cold storage. And this allows you to, let's say, when you get an alert out of your SIEM, say, that's interesting. I'd like to see if there's been any other activity on that IOC when it triggered. So I'm going to do searching on that data in S3, for example. But now once I found it, so let's say my IOC involved these 2 IP addresses, I'd like to reload this data back into my SIEM. I can simply type pipe send like this, and then actually all 32,000 events go back through Stream and can be sent to any Stream destination, including Splunk. So now instead of back to you, I like Roy. I like your the chainsaw a scalpel technique or terminology, right? So now instead of doing a bulk reload, I mean, how many people have had to reload hours or days worth of data into your SIEM when you needed was a tiny fraction of that because you're investigating an incident? Here, it allows you to investigate the incident in Cribl Search and then just send the incident-specific events back into your analytics tool. I mean, imagine how much, number one, how much faster that will be for your analysts. Number two, imagine how much that's going to cut down on reload time and cost. Right? This gives you visibility into the data that you have in cold storage and allows you to act on it. If you can do the analytic in Cribl Search, great, you're done. If you can't, great, reload the data into your SIEM or load the data into your SIEM if it was never there. But it takes what was a black box and now gives you visibility into it. And our vision here is we're going to have, the next release will have dashboards, the next release will have alerts, and in this release you actually have scheduled searches and lookups already. So for example, I can take this, let's see if I can do it off the cuff, right? So let's say I have the IANA lookup file here for destination ports. So for example, if I wanted to do that lookup on service names correlated to destination ports, I should be able to do something like this. So if I have, let's see, limit 100, let's get a quick little sample of that data. And So I have my destination ports over here, something like that, and I can do a extend, and the field is called port underscore number equals destination DST. And again, I'm doing this in real time rather than having to save searches, so you can see that it's not super tricky to do. So now I'm going to do lookup, and I'll take this particular lookup file here, boop, 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 which has, there we go, full names like that. And then we're going to say on port underscore number like that. And now what I should have is anytime I have a destination port that's in the IANA a lookup file, I should have something called service name. And boom, now I have service names in VPC flow logs. And now I can do something really cool like, let's say, summarize count on service name. Service underscore name. No, not that. All right, so now again, I'm getting this data here, which is the IANA lookup for each one of those destination ports on VPC flow logs, which never had that data in it in the first place. Right, so I can take this data and really operate on it however I want. And with the ability to send, now I can take it and do all this data fusion with other data sources that I wasn't able to do before. I can also, for example, do that same kind of process with RESTful APIs. So, for example, here is here's some Okta. So I could quickly, for example, do a search into Okta and see user logins, and and again, you get that exact same result set, and be able to operate on that result set. And again, you see the data is already parsed. You can see we're already pulling out all the fields and for all the field names. And I can operate on that as well. So again, you're giving the user that ability to actually analyze the data in place, right where it is. The same thing, I can do the exact same thing with Azure, for example. So I have a set of data in Azure. I think this is just sort of a flat file that I threw up there. And again, it's just executing the search on the container and pulling that result back. And again, you can have really any flexibility you want in terms of how you analyze that data. Because it's just executing that search on the local compute and giving you your result set. So you have that ability to now federate by simply specifying, if I want multiple data sets, I can simply specify it here with a Boolean combination. So for example, I can do or Cribl Search sample like that. And now it's executing that exact same search in Azure and in AWS at the same time, which I think is super cool. Because again, we are giving you that flexibility to choose. If you want, wherever you put the data, and we have customers that are often conglomerates of other customers, folks who have been acquired, other companies that have been acquired, and they don't have a lot of flexibility. They say to us, well, this is what we got. We got data from this acquisition in Azure. We got data from this acquisition in S3. We have 4,000 AWS accounts. We want to search over. How do we do it? Well, we give you the ability to look at many different types of accounts or different types of data by simply putting wildcards in the path. So for example, over here you can see that this is looking at a particular bucket, Cribl Search example, but we have a specific path element called data source. There's also time inside the parameters as well. So we don't have to look through the entire bucket. Essentially, you're giving search a hint as to where to go look into it. So for example, you can point this at a massive set of buckets or a massive set of data even in a single bucket, like or ASL, where it spans many buckets, and you can ask it the same sort of question. And again, this will search through any text-based data. It'll also sort through 3 different binary data. One I already mentioned, the Splunk data format. It'll search through Parquet data, and it'll search through Journal D, System D, Journal D. So especially if you've got System D running with the Edge agent on those local machines, you can search into Journal D files running on those machines without having to cast them into ASCII first.
Open telemetry?
Yeah, OTel is something that we don't specifically support, but again, if you've got that data in a place where it is in one of those formats, we can search it, right? We're very agnostic to to mission here. I mean, I've got data from my chicken coop coming in here, right? With humidity, temperature, and humidity telemetry. It's very, very easy because there's no loading, right? There's no back-end data store. We're pointing at whatever data store you have available to you and trying to make that data available as a question, right? As an answer to a question.
I sort of remember on the Stream product that Hotel is supported.
It is, yeah, absolutely. So theoretically, you can certainly take the data out of Hotel, push it into any place you'd like as a destination, as long as it's one of the destinations that we can search in Cribl Search. Then boom, you're done. Gotcha. It's very, very straightforward. And I did mention earlier that I intentionally had not parsed the syslog data. I think I turned it off. Let's just check to make sure. And again, built into each one of these data sets is automatic detection and parsing of text events. So, for example, the Cribl Search sample here has what we call, oh, no, I didn't take it out. So it has 3 different data sets of data types built into it, which are essentially detection and parsing engines for rules for text events. Right, so I'm going to disable or just take out this syslog one, right? So now we can, and just save that. So now if I execute a search across this Cribl Search sample, and I'd say I'd like, click, why is clicking not working today? Sorry. Okay, so I'm going to do data source equals syslog, like that, and now I should get a bunch of unparsed syslog. So I'm going to show you this actually really quite cool interface that we have for doing dynamic parsing. So I'm going to go type over here and type extract and hover over extract. And what it's going to do is it's going to give me this cute little preview operator. So this modal will pop up. And now this gives me the ability to interact dynamically with this data without having to go back to the data source every time. So now I've got a local cached copy of it. So let's say I want to extract the priority field here, the stuff in the angle brackets, right? I'm going to say type equals regex. And let's see, so keep your fingers crossed. I'm going to do live regular expression right here without a net, folks. So let's see, I'm going to say regex equals which is the Cousteau escape character. And so we want open angle bracket, open close angle bracket, and I want \d, so that should give me the number, and I'm going to put it in a capturing group like that, and I'm going to say I want to give it a name, so we'll call it, again, angle brackets priority, like that, priority \d, and I'm going to hit preview, and with any luck, boom, got it, nailed it. First try, right? Thank you. Don't ever applause. I appreciate that, Karen. Thank you. But did I get it right? Well, no, not really, because I noticed this one here that has 2 digits didn't get parsed. So what did I forget? Repetition operator, right? So boom, preview, and now I got that one. So now I hit apply, and I hit search, and now suddenly all that data which was unparsed now has a field in it. Now I can operate on it. Right, so imagine this. This is your process. Data is sitting in one of the big object stores, right? You have no idea what it is. We get this all the time. This happens to us constantly. Customer comes to us and says, somebody threw a bunch of data in our S3. We have no idea what it is. Okay, let's work through it exploratively. Is that a word? Let's work through it together. Let's explore it together. So we start doing searches on it. We find a bunch of data and say, hey, those look like IP addresses. Those look like field names. Those look like account names. Let's just give them some field names this way. We'll use regex. That's step 1. Then step 2 is, hey, we're going to go and actually create a parser. We'll create a parser and we'll give it a name. So that data. So for example, here's a regular expression to parse that entire syslog message. So now I can go back into this data, and instead of this whole messy regex, I can just say a parser equals, what do we call it? No, I forgot what it was called. The parser is called syslog custom, I think. Syslog custom, boom, there. And now with that one command, everything that's in that syslog message is now parsed. Now we have fields for this syslog message. That's step 2. Getting a little more sophisticated in terms of modularity and reuse. Now, step 3 is we have these things called data types, and data types are in fact groups of not just parsers but also data detection and field extraction and timestamp recognition and event breakers. So again, if a data type. So for example, this is the AWS data type, and it has 6 different rules, 5 different rules in it. Sorry, my eyes are going. CloudTrail, VPC Flow, ALB, ELB, and CloudFront, and it has the filters, which are detection, and then individual parsing, and it can be regular expressions, Grok, JSON, JSON arrays, comma separated, delimited, field equals value. Basically, any way that you can express field names in there, or divide your data. So then we can take this data type and apply it to the data set. If you remember, I said at the beginning, a data set is a named set of data at a particular data provider, right? So we're going to go back into that Cribl Search sample, go into processing, and say, hey, I'm going to add to the fact that that is, in fact, some syslog data, and I'm just going to move it up in its priority. And now I should be able to ask that exact same question without any extraction whatsoever, and all of those same fields will be extracted because now the parser is built into the data type. That's step 3. So essentially, you have this ability to work your way down into data exploratively and iteratively, which is really how analysts work, right? You kind of dig into it and you're like, oh, I wonder what that is. I want to explore it. And if there's any takeaway that you get from this conversation, it's that this tool works the way analysts work. It allows analysts to do what-if scenarios, explore data without having to pay for it.
So just real quickly, I think you might have heard us today mention a few times that we're pretty passionate about being a customer-centric, customer-first company. And as part of that, we provide free training. And our philosophy here is, why would we charge you to help you learn about our products, right? The more that you learn, the better you'll be at using the product. And that's what we ultimately want, is you to be a happy customer that's using the product in a meaningful way. So we have a certification program. So the only thing better than free training is free training and certification, right? So in our case, not only is the training free, certification is free as well. So you can go to Cribl.io, and on our webpage, if you navigate around, there's a resources section that has a learning section there. And you'll find a link for Cribl University. And within Cribl University, we have 2 certifications today. The first is Stream User, pretty self-explanatory, right? It'll teach you the basics of using Stream. Stream Admin for those that are advanced doing Stream administration. More certifications are coming. You'll obviously see some stuff for Search. Search is a newer product, so as we go from version 1.0 into towards 2.0, we'll finalize the certification there. That engineering team has done such a phenomenal job with Search and moving so quickly development-wise, it's hard to keep up with them with curriculum. So we're getting there. You'll see some stuff for Edge as well linked into the courses. We also have additional courses that aren't just certifications. So if you get certified, you can go to Cribl University. We have modules. We have a new one coming out that's called Custo 101 that'll teach you some of that ninja-like search language that David was just showing you. There's a number of other modules, Edge-specific as well. And one other thing I wanted to call out too that's not part of CCOA, but it's part of Cribl.io, is we have sandboxes as well under the resources and learning section of Cribl.io. So you can go there, you can spin up a sandbox. We have roughly, I think, 5. Oh, look, there's it's in the blocks of success. So you can go spin up a sandbox. And what's happening there is we're actually using Kubernetes. We'll actually spin up a real live instance of Stream for you or Stream and Edge for you. And you can go through a little guided scenario there and get your hands on the product. And if I didn't mention it earlier, and I know I did, you can also sign up for Cloud for free. You get full access to the product, 1 terabyte per day. You can get in there and get as crazy as you want. You'll get access to the search, as David just showed, Stream that Jim showed, and Edge that unfortunately we didn't get to show today, but is very cool. So please check that out if you get a chance. And Nick, I'll go back to you. So we have plenty of time for Q&A here.
Yeah, I just want to hop in real quick. This is Steve, and say thank you. Learning about technology is fun, and more companies should be more open and about this kind of thing. Having the free certs and the free classes is really a big deal to me, and I love these kind of things. So thank you for doing that.
No, thank you. Thank you.
Thank you, Steve. And, I just wanted to, as you said that, I thought of something. our certification program just had a birthday. It's 1 year birthday, and we have just a little over 3,000 people certified in 1 year. And so I just think that's phenomenal. It's very exciting to us. And thank you. Hearing comments like that it just really makes us feel good about the fact that we are offering free training and that we are very passionate about enabling our users and not charging you for that, right? We want to do so because we care about our customers, right? So thank you.
I've had many an argument with senior members of companies where I said, education is not a profit center or an expense. It is a cost avoidance tool for support, and you should start treating it as such and spend money on it.
100%. Steve, we need a quote. We need to get a quote from you there about that. Absolutely.
So just in the last couple seconds, I do want to point out we have a community Slack, and there's around 5,900 folks there. So if you do want to kick the tires on Sandbox, or you want to start playing with Cribl Cloud, and you want help, that is the best place to go. You'll get both help from the community as well as Criblanians that are also in all those channels. So there's always help available.